everyone, welcome back. Today we are going to take a look at composite data types. So what are composite data types? These are the ones which are composed on top of primitive data types. That's the reason we call them composite types. So arrays, tuples or tuples, whichever the way you pronounce, slices, struct, all of these are composite types. Array is a fixed size collection of elements of specific type, which means it can contain fixed number of elements. For example, it can contain only, let's say, 5 I32 numbers or only certain number of F64 numbers. Similar to array, tuple is a fixed size collection, but it can hold different types of data, which means tuple can contain, let's say, 2 I32 numbers and 5 F64 numbers. Basically, we can mix the data of different types. Coming to slice, it represents a reference to a continuous sequence in an array or a vector. Important point to note here is it does not allocate a memory on its own. It just refers to an existing value in an array or a vector. We will take a look at vector in next video. The next composite type is struct. It's user-defined data structure that can hold multiple fields. You can take an example of a person. Person can have a name, age, address, and so on. This type of information can be represented using struct. Now coming to enum, it can be used to define the finite set of values. Again, to express enum, we can take an example of a direction. There are certain values of a direction, for example, east, west, north, south. These are all finite set of values. And to represent this type of information, we can use enum. Let's open our editor to write a code using composite types. In last video, we created a file and placed all the primitive type specific code in it. Let's do the same for composite types as well. So to create a file, right click on the src folder, new, rest file, and let's use composite types as a name of our file or a module. Let's attach this file or module with the main file, main.rs. Now this is attached. Let's go to our composite types module and create a function for an array. As usual, we will add a println statement in here. Now we can create an array variable, let a. This time we are going to specify the variable type explicitly. The type is I32 semicolon 5, and then we will initialize the array. Here I32 is the type of each element in an array. After the semicolon, the number 5 indicates that the array contains 5 I32 numbers. Let's print our array. Here we are using colon followed by the question mark inside the placeholder to print an array variable. Array is a composite type, so it needs special mechanism to print on screen. The syntax is nothing but a debug placeholder. We call it a debug placeholder. Earlier, in case of primitive types, we did not use it, but array is a composite type, so we have to use it. Now let's call our function from the main function. Let's introduce a section for the composite types. Composite types. Then we'll call our function. Just like the primitive types, we have to add a use statement at the top to import all the available functions in main.rs. Let's do that. Composite types : star, which basically imports all the functions from the composite types module. Now we can run our code, and as expected, we are able to see the array in our terminal. There is another approach of creating an array. Let a is equal to, and then this time we are using a different syntax. This snippet says array variable a contains 5 times 3. Let's print this array to terminal and check if we are getting 5 times 3. Let's run our program again, and as expected, we are able to see 5 times 3. Now, if you want to access a specific element in an array, then that can be done using the index. Let's access a specific element from an array. Value at 0th index in array is, and all the array values are of a primitive type, so we don't have to use the debug placeholder in here. Let's try to access the value at 0th index in array, and we are expecting value 3 to be printed on the terminal. Let's run our program, and as expected, we are able to see the value 3. One important point to note here is this approach is not recommended in Rust. To understand the reason, let's take an example. Let's say you have an array in your code which contains 100 elements, and you are asking user to enter the index to access the specific element from an array. Imagine if user enters a number 200, then your program is not going to give the expected output. Because of this behavior only, Rust simply stops your program in such cases. So let's try to access the 200th index. As you can see, Rust is giving an error that index out of bounds array length is 5, but you are trying to access the 200th element. What is the solution? Solution to this problem is Rust recommends you to use the get function to access the specific element. Now we'll change this statement a little. We'll use the get function, but this time we'll keep the 200th index. Error is gone. Now let's run the program and let's see what is the output that we are getting. We are again getting an error because this get function essentially returns another complex type, and complex type need to be printed using a special placeholder, which is a debug placeholder. Let's do that. Now if we try to run the program again, we can see the output, and the value at 200 index is none, which means there isn't any value at 200th index. Here the takeaway point is always use the get function to access the element rather than using an index. Moving on to tuples or tuples, let's create a function for it. Tuple types, let's add a println statement. Now we can create tuple variable, let tuple 1, and then we are going to give an explicit type. And for the tuple, we have to use the parenthesis, and inside parenthesis, we have to define the type which tuple is going to hold. So let's say I32, F64, and U8. Let's go with this suggestion. Here, as you can see, our tuple, it contains values of different types. It contains value of I32, it contains value of F64, as well as a value of U8 type. Similar to array, we have to use the debug placeholder to print tuple on the terminal because it is another complex type. Let's add a println statement, and we will use the debug placeholder syntax rather than the simple placeholder because tuple1 is a complex type. Let's call our function from the main function. Let's go back to the composite types. Now, if we run the program, we are expecting tuple details to be printed on the terminal. As expected, we can see the tuple details on the terminal. Take a scenario where we want to access a specific value in a tuple. This can be done with the help of value index. Similar to array, first value in tuple has a 0 index and second value has index 1. With that said, we can print second value of our tuple using the index 1. Let's add another println statement, and we'll use .1. So .1 is the way of accessing value in a tuple, and 1 is nothing but the index of the value. In our case, 500 is sitting at index 0, 6.4 is sitting at index 1, and value 1 is sitting at index 2. So here we are expecting value 6.4 to be printed on the terminal. Let's run our program. As expected, 6.4 is printed on the terminal. Now if we want to assign each value in a tuple to a variable, then we can use the destructuring pattern. So the destructuring pattern looks something like this. Let ABC is equal to tuple1, and we can add a println statement for each value. Essentially what we are doing here is we are taking out the values from tuple1, assigning them to a variable. So A is referring to value 500, B is referring to value 6.4, and C is referring to value 1. Let's run our program and let's see the output. We are able to see the value of A, B, and C. There is a special tuple type which is referred as a unit type tuple, and its syntax looks something like this. Let tuple2 is equal to, and just opening closing bracket. So here we are not putting any kind of value inside the tuple. We are just creating an empty tuple, and this empty tuple is called a unit type of tuple. We will revisit unit type tuple when we talk more about the functions and their return types. Next composite type in our list is a slice. Let's create a function for it. Pub fn slice type, and as usual we'll add the println statement. As we mentioned some time back, slice is nothing but a reference to a part of the array or a vector. So to create a slice, we need an array. We can create a simple array of numbers. A is equal to 1, 2, 3, 4, 5. We have an array, so we can now create a slice out of it. So let's create one. Slice 1 is equal to and A and then opening closing bracket, and inside that we have to specify the range. This is 0th index, this is first index, this is second, and this is third. So the range that we are specifying here is 1 to 3. So the value at first index is 2, value at second index is 3, and value at third index is 4. But the last number that we use in a slice is exclusive. That means the number at third index will not be part of our slice. Expected output in this case is 2 followed by 3. Let's print it and let's see if we are getting the expected output. Let's call our function from the main function and go back to the composite types. We can run the program, and as expected, we are able to see value 2 and 3 because the range that we have specified is 1 to 3 and 3 is exclusive number, which means only value 2 and 3 are referenced by the slice 1. Again, as we talked, slice is just referring to the part of an array. It's not really allocating any memory on its own. And if you have noticed, we are using the debug placeholder here as well because slice is again a complex type. Next composite type is a struct. Let's create a function for the struct. We mostly use struct type in Rust, so let's try to understand how to create one and how to use one. So let's add one println statement as well. To create a struct, we have to use the struct keyword followed by the name of the struct. Let's create one struct person and then opening closing bracket. Inside the struct definition, we have to declare the fields. So for this person struct, we'll add two fields. One is name, which is going to be of string type, and second one is age, and we will use the u8 in this case because u8 is sufficient enough to hold the age number. We just created the structure. Consider it as more of a blueprint which we can use to represent the actual person. And the way to represent the person is by creating an instance of the struct. Let's create an instance of a person struct. Let gen is equal to, and then the name of the struct followed by the opening closing brackets, and inside that we have to initialize the fields. Name is of a string type, so let's create a string colon from, and inside from we have to give the actual value, in our case a gen, and the second field is age. Okay, let me correct the spelling, age, and let's give one random number, and this is nothing but a statement, so every statement we have to close using the semicolon. Okay, so we do have one instance. Just like array and tuple, struct is again a complex type or the composite type. So we have to use a debug placeholder if we want to print struct on the terminal. So let's add a println statement in here, and we'll print a struct instance, and we'll use the debug placeholder. Let's pass the instance variable in here. If you notice, even after using a debug placeholder, we are still getting an error, and error says person does not implement debug. The important point to note here is every time we use a complex type along with a placeholder, we have to make sure that our struct is having one special annotation, which is derive debug. Let's annotate our struct. And the way of annotating is hash, then square bracket, and then derive. Inside that we have to specify debug. This is a special annotation that we have to use on our struct type. This is basically a way of saying that our struct can be printed using a placeholder. We call this special annotation a macro. Macro is more like a metadata, which we will understand in depth in future videos. As we already have added a macro on our struct, let's call our function from the main function, and then we can run our program. Here we are able to see the struct output, which is our string that we are printing in the println statement followed by the struct details. Now let's take a scenario where we just want to access the specific field of the struct, which can be done using a dot notation. Let's access the name of the person instance, println, and inside that name of person is, and we'll use the simple placeholder because string can be printed using a simple placeholder. The way to access the name is Jane, which is the instance variable name dot name, and if we run the program, we should be able to see the Jane in our output. As expected, we are able to see the Jane in our output. The last composite type is enum. Let's create a function for enum as well. Fn enum types, Let's add a println statement as well. Just like struct, for enum, we have to use the enum keyword followed by the name of the enum. Let's create our enum direction followed by the opening closing brackets. Now for the fields, enum works a bit differently than the struct. We just have to list all the possible values for the enum. In our case, direction can be presented using north, east, south, and west. These are the possible values for the direction. One major difference between struct and enum is, in case of struct, we had to create an instance of the struct explicitly. But for enum, each of its value is nothing but an instance of enum itself. Let's add one println statement and let's print one of the value, and east direction value is, and we'll use a special placeholder because each value is nothing but an instance of the enum. So in this case, the way to access the enum value is direction colon colon and the specific value that we want to access. As we can see, if we take a mouse over here, we're getting the same error. Let's add our macro for special annotation, derive debug. Now let's use our function of it and let's put it in the main function. If we run our program, we will be able to see the enum value. In this case, east direction value is east. Always remember, whenever we use the debug placeholder, it expects the replacement value to have a debug macro or implement a debug trait. That's all about the composite types. In next video, we will take a look at the utility types. Until then, happy coding.